Hey everybody, in this video I want to talk about box plots, how we make them, and how you can use them to describe a shape of a distribution. So by this point, you should have watched my videos to learn how to calculate a mean, how to calculate a standard deviation, how to calculate a median, and how to do a 5-number summary or an interquartile range. So right now, we know how to use numbers to describe distributions. So we can talk about its center with a mean or a median, or how spread out it is with a standard deviation or an interquartile range. Where I want to take things in this video is how can we take a data set and represent it graphically so that we can look at data sets and describe them in other ways. So how we're going to do that is we're going to use a box plot. So you might have heard about these before as box and whisker plots. I'm sure you've probably seen them before. If not, you'll see them. And we're going to talk about how they're actually made. So we're going to talk about what does it look like, what pieces correspond to which parts of the 5-number summary. So a box and whisker plot, or a box plot for short, does have a box, and it has two whiskers, a whisker on the left side and a whisker on the right side. Okay. Typically with a box plot, though, we want below it some sort of number line. Okay, some sort of number line. The whole purpose of this number line is different parts of the box, like this vertical part right here, this vertical segment here, this vertical segment here. Those all correspond to some important pieces of our data set. So if I can look at where this whisker ends, I could use the number line down here at the bottom to kind of know which number coincides with this piece of the box plot, which number corresponds with this piece of the box plot. That's why you want to provide that number line, so you can have a little bit of context on what is going on there. Okay, so here's how a box plot works with a 5-number summary. So if you watched my previous video, you know our 5-number summary has a minimum, quartile 1, median, quartile 3, and a maximum. So what happens is all these little vertical segments here are actually my 5-number summary. On the left end down here, this point will coincide with our minimum. This vertical part in the left side of the box, this is actually my Q1, quartile 1. So whatever quartile 1 is should match up with the number line down here. The middle here of the box is going to be our median. The right end of the box is going to be our Q3. So if you notice, I'm kind of going in order of my 5-number summary. So the highest point here on the right, the end of that whisker, is going to be your maximum. So we have our minimum, Q1, median, Q3, max, all coincides with those different pieces of the box plot. Okay, so if we know the 5-number summary, you can create a box plot. So what I would like to do is a quick example on actually creating a box plot. So I have this data set provided. Okay, I do not know the 5-number summary for this yet, so I need to do that. So remember, with the 5-number summary, we're all about trying to calculate some medians here. So it helps to put the data in order from smallest to largest. So my smallest data point being a 5, my next data point being a 14. I got two 16s in there, so 5, 14, 16, 16. After that, looks like we got a 20. Then we got a 22. Then a 28. Then a 30. Okay, so I typically start with a 5-number summary doing either my min-max and then my median, and I worry about Q1 and Q3 last. So the very smallest value, that is my minimum, so we have a minimum of 5. The largest value, or my maximum, is going to be 30. And now I just got to start with my median, then I'll move on to Q1 and Q3. So again, start with the outer two, and you can easily count your way in because we're trying to find that middle value. So there's 2, moving 1, moving 1, moving 1. And it looks like our median is going to be somewhere between 16 and 20. So I kind of put a dash there this helps me signify, hey, that's my lower half, this is my upper half. So my median needs to be an average of just those two numbers. So I do 16 plus 20, which is 36 divided by 2. You're going to get a median of 18. Okay, so now to do Q1, that's the median of my lower half, so I'm dealing with just those 4 numbers. So going in, I'm going to be stuck between 14 and 16, so I would need to do an average of 14, 16, which you could easily take a calculator, 14 plus 16, divide it by 2. You're going to find Q1 is going to be 15. Same thing on the upper end, line them up, least to greatest, find the median of the upper half. It's going to be between 22 and 28. So I need to add 22 plus 28, which is 50, divided by 2. That is 25. So I now have my 5-number summary. So what I need to produce is I'm going to take these different pieces to create my box plot. But the first thing I want to talk about is that number line. So I know the lowest point I need is a 5, the highest point I need is 30. So I just want to make sure I provide that on my number line. So number line at the bottom is going to help us make it. I'm going to start mine at 0. You don't need to label every single piece. So let's do 0. There's 1, 2, 3, 4, 5. And I have to get up to at least 30. So there's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. I don't need to keep labeling on. We're good to go. Okay, so again, the box plot, you need 2 whiskers and you need a center box. So it's all about small vertical segments of these points. So 5, this is going to be, I'll put it right above 5. There's my minimum. Q1 needs to be at 15, which is going to be right here. Median at 18, which will be right there. Q3 at 25. There we go. Maximum at 30, which is right here. So the middle 3 is what's going to make your box. So you always have a box, a lower line, upper line, median in the middle. The 2 extreme pieces, my min and max, are going to help me make my whiskers. So you're just going to do horizontal lines all the way out to each of those segments. That would be my box and whisker plot for this data. Okay. So it's just another way of taking a data set and trying to visualize it. Okay. Why this is important to us is we can talk about some shapes of these box plots. So there's various shapes we need to look out for. The 3 that we kind of see is one that's going to be like this. That's one example of a box plot you may see. You might see something like this. And then our last type of shape, something like this. So when we talk about shapes, it kind of goes back to what you've kind of heard in geometry. This first one is pretty balanced on the left and right side. The box here is pretty balanced, about even on both sides here. The whiskers are pretty balanced as well. When you see this, this is what we call symmetric, okay? Symmetric, which means it's pretty much the same on both sides. My other 2 shapes are a little bit different, okay? If you notice this box plot over here, just a rough sketch, it really stretches out and gets long on the left side. So the whisker is really, really long on the left side, short on the right side. The left side of the box really stretches out on the left side, but it's short on the right. So we really stretched out the shape on the left side. This is what we call skewed left. So when it stretches out to the left, it's skewed left. Related to this, this other box plot I have over here is pretty short pieces on the left side, a short whisker here, short part of the box, but we stretch out on the right side of the box, we stretch out on the right whisker. This is what we call skewed right, okay? So we have skewed left, symmetric, and skewed right. So that's how you can take a data set, you create a box plot, and you can kind of look at the shapes here. Kind of what these means is when you're skewed left, that means you have a lot of data in this area right here on the right, but it kind of, all the data points really, really spread out on this left side. Over here, compact data here, but everything really spreads out on the right side. When you're symmetric, you kind of have some balance here. You don't really have things stretching out one way or the other. The data is pretty evenly kind of distributed around, okay? So we talk about it being symmetric, okay? So it's another way of kind of visualizing data. You also can kind of see the spread here. So we're really spread out on the left side, really spread out on the right side. Last little example I want to do is commenting on the shape of these two examples. So on this left, this is a height of trees box plot. Notice the number line. They don't exactly need the vertical segments here. That's just something I like to do. Both are fine. So looking at this, you see it's pretty short here for this right whisker, right side of the box, left side of the box, pretty small as well. But this left tail really stretches out. So since it's stretching out on the left side, we're going to call this skewed left. Our next one, we have roller coaster speeds in miles per hour. Again, a number line. There's the minimum, Q1, median, Q3, and the maximum. And then there's this point over here. We'll come back to that. But if you look at this, you know, we have pretty short pieces here, but it stretches out here on the right side. This is skewed right. The reason why I included this example is there's one other statistical idea out there that is this guy right here. This is what we call an outlier, okay? An outlier. It's represented typically on box plots by a star. And what those are is they're a data point that is much smaller or larger than all the other data points. It really looks like it doesn't belong. So if we had these actual data values, you know, it looks like we have numbers between 40 and 90, but a lot of the numbers are kind of down in here because it's much skinnier in here. So you probably have data points in 40, 42, 48, 50, you know, 62, maybe something up at 70, a few in the 80s, etc. Then all of a sudden there's this random data point that really doesn't look like he belongs. He's nowhere close to the rest of these. So that's what makes him an outlier. And this is an outlier on the upper end. Okay? Another just little statistical idea that you can deal with. So to recap, what we talked about is how the 5-number summary can help produce box plots. When we have box plots, you can kind of visualize how spread out things are, and you can also talk about the shape. And that concludes this video and our little introduction to statistics.